Given a binary tree, find the maximum average value of any subtree. What is a subtree? A subtree is the node plus all its descendants. So if you have a binary tree that looks like this, 6 subtree is just itself. It has no descendants. 1 subtree is itself, 5 subtree is itself plus 6 and 1. The average value is the sum of its values and its descendants divided by the number of nodes. The number of nodes is sort of like the node count of itself plus its descendant count. So the 6 node for the node of 6, node count will be 1. 1's node count is 1. 5's node count will be 3 because itself plus left count plus right count. And the final result is the maximum average value. So you need to visit every node and find out what the average value is and get the maximum. For this node, 6 divided by 1 is 6. For this node, 1 divided by 1 is 1. For this node, 5 plus 6 plus 1 is 12, divided by node count, which is 3, equals to 4. That's why the maximum is 6. A slightly better example is a tree that looks like this. So let's examine every node. For the node of 0, there's no contribution from the left or the right child. So no contribution in terms of sum, no contribution in terms of count. The average value will just be itself divided by node count, which is 1. For the node of 6, there is contribution come from the left. The left contribute the sum of 0 and a count of 1. There's no contribution from the right. So the result will be my value plus contribution from the left. So 6 plus 0 divided by my contribution of count from the left plus 1, because that 1 is myself. For the node of 4, there's no contribution from the left, no contribution from the right. So the result, the average, will be my value divided by a count of 1. For the node of 2, contribution comes from the left is 6. The count will be 2. Contribution from the right is 4. Count is 1. So the average is contribution from the left, which is 6, plus 4 plus myself, divided by count, which is 2 plus 1 plus myself, which is 3. Now, the maximum of every node's average, 0, 3, 4, 3, is 4. So you can sort of see every node is making a query of the result from your left child and the right child. Every node is asking questions to their left child and right child. What is your contribution in terms of total sum and total count, right? For example, this node of 2 is making a query, my left child, what is your contribution in terms of sum? The left child returns, well, 0. The count is 1. It's making a query of the right child, what is your contribution in terms of count and the sum? Since it's null, the sum is 0, the count is also 0. Do note, there's a difference between a node of value 0 and a null node. The difference is the the now node does not contribute count, while a node of value 0 has a contribution of count. So in a way, you can think of the left child to drag it down, right? Because it dragged down the average. The right child does not drag it down because it does not contribute a count. So let's do the recursive call. Note we are making a query of two values, the sum and the count, so we can use a return type of a pair, right? Call it. Now if this root is a null node, the contribution is 0 in terms of well, we can make the first be total sum, the second be the total count. The order doesn't really matter as long as you are consistent. So the first guy is total sum. The second element is total count, just so we are not confused. If it is a null node, total count and total sum both are 0. Then we do recursive call to the left. Then we do recursive call to the right. Now this is where the node needs to make a decision. It needs to make a decision that updates the global result, right? We have a result here. Every node you need to make a calculation. Okay, what is my average value? What is my average value? What is my average value? You need a global maximum to keep track what is the maximum average value. So we need to pass in a global. Global result, let's call it res. In order to update it, we need to pass in reference. Let's initialize res as to be negative because the node value will be positive. So a negative res will definitely be smallest. That's why you can update it. You need to store this. The calculation is the sum divided by count. Sum comes from left dot first plus right dot first plus myself. Let's cast this to be double. The count is left dot second plus right dot second plus 1, right? Because that 1 is myself. Return my average, which is, no, you are returning total sum and the total count as far as I am concerned. So you have first plus right dot first plus myself, left second plus right second plus 1. In the end, you return res. Let's pass in res. Hit submit. There we go. Let us now do JavaScript. What I'm gonna do is a copy paste my solution in C++, use a constant to make the function call. Now in JavaScript, you cannot pass a primitive by reference, so you have to make it global. By it, I mean res. Call it, return res. Now, if root is null, use an array. Auto becomes const dot remove the res math, no need to cast dot first become array operator same array operator dot, oh boy, check for syntax error. There we go.